Number 1 gives us point A and B on the unit circle, and it says that they make angles of theta with the positive x-axis. Part A would like us to select all of the angles represented by the same point as point A. And when we look at each of these, we see that each of these are pi over 6 radians. So remember that pi is half of the unit circle, since the whole thing around is 2 pi. So 1/2 of it is pi, and if we're in sixths, then we can look at splitting that top half into 6 pieces or the whole thing into 12. And that's what we have on this picture. So then you can just look at kind of counting, if you want to, the number of pi over 6s. And remember that going up is positive and going down is negative. So on this first one, we're going negative 17 pi over 6s. So this is 1, 2, 3, 4, 5, 6, and again, negative. And then negative 12 would be all the way around, negative 18. So this one would be negative 17. And you could count them by ones if you wanted. So negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So this is not in the same spot as point A. So this is not one of our angles. So then we'll start over. For the next one is positive 5 pi over 6. So 1, 2, 3, 4, 5 pi over 6. That one lands at the same place as A. So that is one of our coterminal angles. Positive 17 pi over 6. So we're going up. So again, this is 6, 12, 13, 14, 15, 16, 17 pi over 6. Positive lands on A. So that's good. D is 18 pi over 6. Well, if 17 pi over 6 is right here, then 18 pi over 6 would be here, and that's not going to be on point A. And then negative 7 pi over 6. So let's go back to 0, and now we're going to go negative. So negative 1, 2, 3, 4, 5, 6. Negative 7 lands on point A, so that would be good. Whoops. Part B lists 3 different angles that would have the same coordinates on the unit circle as point B. So now we're looking at point B, and we want to name 3 different angles that would have that. So our first one, and if we look at this, you're looking at that pi again. So here's pi, and this one is just splitting pi into 2 equal angles. So this one would be pi over 2. If we went positive, so positive 1 pi over 2, we could look at going negative if we wanted to. So negative would be negative 1, 2, 3 pi over 2. And if you wanted, you could even just name it with pi over 6s. So if we named it with pi over 6s, that would have been 1, 2, 3 pi over 6 if you wanted to do that. And there's a million different ways you can do this. So you could do a lot more angles to this. That's just 3 examples. Part C, use sine and cosine to express the exact coordinates of point A in terms of theta. And so when we do sines and cosines, remember cosine is for the x coordinate, and then you put the angle measure in. And remember this, you could really use any of these angles that you found. I'm going to use 5 pi over 6. And so then we would do cosine of 5 pi over 6, comma, sine of 5 pi over 6. So sine is your y value, cosine is your x value. So then that would be the ordered pairs in terms of sine and cosine. Then it wants us to label 2 new points that have a tangent of 0. And remember that your tangent function is equal to y over x. And so we want this to be 0. Well, the way that you get a number to be 0 is if you have 0 on top. So 0 divided by any number is equal to 0. So we want our y coordinate to be 0 on the unit circle. And so that's going to happen here. And it's going to happen here. So we could label this as point C and this as point D. So at the ordered pair of 1, 0, that's going to have a tangent of 0. And at the ordered pair of negative 1, 0, that's going to have a tangent of 0. Number 2, complete the table by writing whether each function is positive or negative in each quadrant. And so remember that the sine value goes with our y coordinates, the cosine value goes with our x coordinates, and then our tangent is y divided by x. So that's really what we're looking at in these quadrants is the x or the y positive or negative. So remember in the first quadrant, they're both positive. In the second quadrant, the x is negative and the y is positive. Third quadrant, they're both negative. And fourth quadrant, we have a positive x and a negative y. So in the first quadrant, this is really, when we say sine, we're saying is the y positive or negative? And the y is positive in the first, positive in the second, negative in the third, and negative in the fourth. The x coordinate is positive in the first, negative in the second, negative in the third, and positive in the fourth. Then the tangent, we divide those. So a positive divided by a positive is positive. Positive divided by negative, negative. Negative divided by negative is positive. And negative divided by positive is negative. So that's how you figure out whether the functions are positive or negative in which quadrant. Number 3, explain how you know each of the following statements are true. So how do we know that the sine of 7 pi over 6 is the same, the cosine of 7 pi over 6 is the same as the cosine of negative 5 pi over 6? So if we take a look at our sine and if we take a look at our unit circle, when you look at 7 pi over 6, if you follow, this would be 6 pi over 6, here would be 7 pi over 6. And then if we went negative, this would be negative 5 pi over 6. So they represent the same angle. So they're coterminal. So they're going to be equal to each other since they're coterminal angles. Part B gives us sine of 5 pi over 4 and then sine of 13 pi over 4. So pi over 4s, remember, split your top half in 4. So we'd have 1, 2, 3, 4. Those are our pi over 4 angles, and we could extend those also for the whole unit circle if we wanted. So when we're looking at this, then 5 pi over 4, so 1, 2, 3, 4, 5 pi over 4 is going to be here. And then 13 pi over 4, so that would be 4, 8, 12, 13 pi over 4 is going to land here again. So again, these are coterminal, so they're going to be equal to each other. Part C, why is cosine of 11 pi over 6 greater than sine of 11 pi over 6? So 11 pi over 6, if we think of splitting this into 6, this would be 6. This would be 12 pi over 6, so that's going to be right before here. So here's that angle. So this angle is going to be at a positive x coordinate and a negative y coordinate. And we know that the cosine is always the x coordinate and the sine is always the y coordinate. So at this angle, the cosine is positive and the sine is negative. So cosine has to be larger. So cosine is greater because it's positive and the sine is negative. And then part D, why is sine of 4 pi over 3 less than sine of 2 pi over 3? So sine of 4 pi over 3, if you think of splitting this top half into 3 equal pieces, you've got 1, 2, 3 here. So this is what pi over 6's look like. Pi over 3's look like. And so if we go to 4 pi over 3, this would be 1, 2, 3, 4 pi over 3 would be right here. So that's this one. And then 2 pi over 3 would be 1. 2 pi over 3 would be right here. And so if we think about sine again, sine in the second quadrant is a positive because the y is positive, and sine in the third quadrant is a negative because the y is negative. So then this one is negative because it's in quadrant 3, so it has to be less than a positive number. And then the sine of any angle in quadrant 2 is greater than the cosine in quadrant 2. So when we're in quadrant 2, the cosine is going to be negative and the sine is going to be positive. So the sine has to be greater because it's positive and the cosine is negative. Number 4, given the sine of an angle in quadrant 2 is 0.5, find the value of cosine of theta. So this one, we have that sine squared of theta plus cosine squared of theta equals 1. This is a Pythagorean identity that we know. And so we can plug this information in. So given the sine is 0.5, so we're going to do 0.5 squared plus cosine squared is equal to 1. So 0.5 squared is 0.25 plus cosine squared is equal to 1. So then we'll subtract 0.25 from both sides. And we'll get cosine squared of theta equals 0.75. So then you would square root this. So the square root of 0.75 is equal to, so theta is equal to plus or minus 0.866. So now I need to figure out which one it is. And we're in the second quadrant. So if we're in the second quadrant, that means that the cosine is negative because we would be here. Okay, somewhere in the second quadrant, this x value is negative. So theta is going to equal negative 0.866. Number 5, given the cosine is in quadrant 2 is negative 0.4. So we're doing this same kind of idea here. So we're looking for sine squared this time. So sine squared of theta plus negative 0.4 squared equals 1 because that's our cosine. So we have sine squared of theta plus, and 0.4 squared is going to be 0.16, and positive equals 1. So then we'll minus the 0.16 from both sides. So we get sine squared is equal to 0.84. Then we'll square root both sides. And again, we'll have two possible answers. We'll have a positive or a negative 0.9165. And we're in the second quadrant again. And in second quadrant, right, the y is positive. So the x is negative. So the cosine is negative, but the sine is positive. So this is going to be a positive 0.9165 for this angle. Number 6, given the cosine of theta in quadrant 4 is 0.74, find the value of sine. So we have sine squared plus 0.74 squared equals 1. So 0.74 squared is 0.5476. So we'll subtract that from both sides. And we get that sine squared of theta is equal to 0.4524. And then we'll be able to square root that. So then we end up with that sine of theta could either be positive or negative 0.726. And we are in the fourth quadrant. So the fourth quadrant has a positive x and a negative y. So this is going to be a negative sign. So we want negative 0.6726 for the sign. Number 7, complete the table by stating whether each function is positive or negative for the stated angles. We're going to want to figure out what quadrant the angle is in first. So when we take a look at 19 pi over 4, remember that we'll be splitting the unit circle into 4. So the top part into 4 equal angles. And that's going to look like this. So we'd have 1, 2, 3, 4 pi over 4s for that top half. So then I'll just extend these for the bottom half, and that'll help us to count. 19 pi over 4, we'll start by going up. So this will be 4, 8, 12, 16, 17, 18, 19 pi over 4 is the second quadrant. So that's a negative x and a positive y. So our sine is going to be positive since it matches the y coordinate. Our cosine is going to be negative since it matches the x coordinate. And our tangent, we divide sine by cosine, and that's going to be negative. Second one is a pi over 3 angle. So let's take a look at splitting the unit circle, the top half, into 3 equal angles. So here's 1 pi over 3, 2 pi over 3, 3 pi over 3. And if we extend those, they look like this. Then we'll count to get this negative 11 pi over 3 angle. So we'll go down. So negative 3, negative 6, negative 9, 10, negative 11 pi over 3 will be here in the first quadrant. And in the first quadrant, everything is positive. Y coordinate is positive. X coordinate is positive. When we divide a positive by a positive, that gives us a positive for the tangent. Third angle is 23 pi over 6. So we'll be taking this unit circle, and the top half will be splitting into 6 equal pieces. So we'll be taking and splitting each kind of fourth into 3. So there's 1, 2, 3, 4, 5, 6 equal pieces. So then we'll just extend this so that we're able to count the whole way. So each of those is a pi over 6. We need 23 of them in a positive direction. So this will be 6, 12, 18, 19, 20, 21, 22, 23 will be right here. That's in the fourth quadrant. That has a positive x and a negative y. So our sine is negative, our cosine is positive, and tangent is dividing a negative by a positive, so that's going to be negative. Number 8, the angle 5 pi over 9 is not an angle we've seen on the unit circle, but it's still possible to find the coordinates of that angle on the unit circle. Use cosine and sine functions to write the exact coordinates, then find the approximate. So when we're writing the exact coordinates in terms of sines and cosines, remember that the x value is the cosine of the angle. So cosine of 5 pi over 9. And then the y value is the sine of the angle. So sine of 5 pi over 9. So there would be your exact coordinates. Then you'll just type this into your calculator. Make sure that you're in radian mode, since these are radians. So you'll do cosine of 5 pi divided by 9, and you'll get a decimal of negative 0. What does it want us to go? 2 decimal places, negative 0.17. And then sine of 5 pi divided by 9 is 0.98. And then I like to draw a sketch to make sure that these make sense in case I type something in wrong or have my calculator in the wrong mode. So if we were going to take and split this top half by 9, right? So if this was 9 pi over 9, because that's 1 pi, then halfway through would be 4.5 pi over 9. So our angle is going to be really close to halfway, right? But just on this side. So it would make sense that our x coordinate is negative and not very big negative. And then that our y coordinate is almost equal to 1, since that's pretty close to straight up. So it's pretty close to 0, 1. So this makes sense. So then I know I calculated correctly. Number 9, 2 graphs are pictured. Which graph represents cosine and which graph represents sine? So remember, cosine on our unit circle at 0, okay, at 0 theta, this ordered pair is 1, 0. So when theta equals 0, cosine equals 1. When theta equals 0, sine equals 0. So sine is starting at 0. So this graph 1 must be our sine function. And graph 2 at 0 is starting at 1. So this must be our cosine graph. Number 10, the graphs below represent cosine, sine, or neither of these. Label each as cosine, sine, or neither. So we just looked at that. Cosine starts at a maximum or at 1, and then is sinusoidal like this. It goes up and down. So this one is cosine. And then this one also starts at a maximum. So this one is cosine as well. Sine starts at 0 and does these kind of hills and valleys. So this one is sine. This one is starting at 0. So this one is sine. So that leaves these ones as neither, since they do not look like either the sine or the cosine function. Number 11, a wheel with a 7-foot radius spins in place in a counterclockwise direction. Complete the table showing the radian angle measure for the rotation and the distance P travels when the wheel makes each rotation. So this is a rotation halfway around the circle for this first one. So halfway around the circle would be to here. And that's going to be a radian of pi. And when we figure out how far it travels, okay, so the distance that the angle travels is called the arc length, and that's always equal to the radian measure times the radius. So if in this first one, theta is pi, then the measure that it travels is pi times 7, or 7 pi, since theta here was equal to pi. Next one, 3/4 of the way around the circle. So here's 1/4, 2/4, 3/4 of the way around the circle. So this is a theta measure actually of 3 pi over 2. And so we will do 3 pi over 2 times the radius. And that's going to mean that it traveled 21 pi over 2 feet. One full rotation is considered 2 pi for our theta. So then this travels 2 pi times 7, which is 14 pi feet. And then 1 1/4 rotations is going to go all the way around here and then 1/4 of the way further. So if we count these are pi over 2. So this would be 1, 2, 3, 4, 5 pi over 2 for our theta. And so that's going to be 5 pi over 2 times 7, which is 35 pi over 2 feet for how far it traveled.